purpose of this lab was to determine the enthalpy change in kilojoules per mole for calcium chloride and ammonium chloride using calorimetry. A calorimeter is a device used to experimentally determine the amount of heat associated with a reaction.
Enthalpy is the energy associated with the breaking and forming of bonds in a chemical reaction. The enthalpy of reaction is the change in the enthalpy of a chemical reaction that occurs at a constant pressure. It is a thermodynamic unit of measurement useful for calculating the amount of energy per mole either released or produced in a reaction. If the value is positive, the reaction is endothermic, meaning heat is absorbed from the surroundings. If the value is negative, the reaction is exothermic, meaning heat is released into the surroundings.
To start off, you will need the following: 2 large styrofoam cups, 2 empty 600 milliliter beakers, 1 250 milliliter beaker filled with water, 2 scupulas, a graduated cylinder, 2 thermometers, an analytical balance, and 2 weigh boats. To successfully perform the experiment, the following steps must be taken. First, you will need to fill one of the styrofoam cups with 100 milliliters of water using the graduated cylinder. Be sure to keep the styrofoam cup secured inside one of the 600 milliliter beakers. Record the initial temperature. Then, using a weigh boat and an analytical balance, measure approximately 1 gram of calcium chloride. Add the 1 gram of calcium chloride to the water in the styrofoam cup and record the final temperature. Repeat this process again using new materials and ammonium chloride.
Now for calculations. We will be starting with the theoretical calculations. Using the balanced dissociation reaction of calcium chloride, plug in the given enthalpy values, which will be seen in red, into the formula enthalpy equals the sum of the products minus the sum of the reactants. Remember to multiply by the moles of each substance and don't forget units. Solve, and now you have your theoretical enthalpy change. The same steps are then repeated for ammonium chloride using its given values given in the lab directions. Now for experimental calculations. Using the data from the lab seen here, plug those values into the equation Q equals mass times specific heat capacity times delta T. Then convert that value to kilojoules. Because we are technically solving for the enthalpy change of the water, use the property heat of the system equals the negative heat of the surroundings to find the enthalpy change of the calcium chloride. Next, convert the mass of the substance used to moles. Then put the kilojoules found from Q equals mc delta T over the moles of the substance and solve. Now you have your experimental enthalpy change. The same steps can then be repeated for ammonium chloride.
This experiment was done using an open coffee cup calorimeter. Therefore, heat released by the reaction into the surroundings could have escaped from the calorimeter and therefore not have been accounted for via the surroundings change in temperature. This would then affect the experimental enthalpy change when using the equation Q equals mc delta T, because the Q would be lower than the actual amount. This error could have been minimized by covering the top of the coffee cup calorimeter. Therefore, heat would have not escaped into the experimental surroundings. The temperatures recorded in this experiment were taken using a thermometer rather than a lab probe. Therefore, the temperature changes recorded were not as exact, thus affecting the experimental enthalpy. This error could have been avoided by using a laboratory probe to record temperature changes. Only one trial was done for each solution, therefore the experimental data was not determined to be accurate or precise in regards to solely the experiment, not the theoretical data. By performing multiple trials, errors regarding accuracy could have been avoided, thus resulting in a smaller % error when the experimental data was compared to the theoretical.
What do all these calculations and results mean? By calculating the change in heat, you can determine whether or not the dissolving of calcium chloride and ammonium chloride are endothermic or exothermic reactions. Based on our results from the lab, it can be concluded that ammonium chloride was endothermic and calcium chloride was exothermic. These were calculated using Hess's law, which is change of heat equals sum of the products minus sum of the reactants, and Q equals mc delta T divided by the moles of the solid using during the lab. Both of these formulas calculate the heat produced in the reaction.
In addition, the accuracy of conducting this experiment can be found by calculating the theoretical and experimental change of heat and then finding a percent error. This helps to show how accurate or inaccurate the lab conducted was. Based on the results and the places for error, this experiment should not be used to determine the actual enthalpy change for a solution.